There's a common saying that dilution is the solution to pollution. People have made a practice of dumping all kinds of contaminants into rivers, lakes, and oceans. The idea was that a large volume of water would dilute pollutants enough to make them harmless. However, some contaminants, no matter how diluted, stay in water and accumulate in the food chain, causing harms to plants, animals, and people. The pollution may be hard to detect. Water with diluted contaminants may look, smell, and taste just like clean water. Allie and her students visit beaches and take water samples so they can determine if dangerous microorganisms that we can't see have leaked into the ocean. Let's do an investigation that helps Allie answer the question, is dilution the solution to pollution? We are going to use a technique called serial dilution. Serial dilution is the step-by-step dilution of a substance in a solution. Serial dilutions are widely used in biology, chemistry, and physics to quickly make very dilute solutions. In our experiment, the dilution factor is 1/10. This means that the concentration of the initial solution will decrease by a multiple of 1/10 with each dilution. We will be using liquid RIT dye as our initial solution. RIT dye is made by adding 1 part solid dye to 9 parts water, which makes a 10% RIT dye concentration. Our first well, well number 1, is filled with this 10% solution, at least 10 drops. Then in each successive well, the dilution will be 1 part or 1 drop of dye solution from the previous well with 9 parts or 9 drops water. The resulting dye concentration of each well will decrease by a multiple of 1/10, which is our dilution factor. Let's calculate the dye concentration in the first few wells. The initial concentration of well number 1 is 10% RIT dye solution. If we take 1 drop of this solution, place it in well number 2, and add 9 drops of water, then we are diluting our initial solution by 1/10. This means the dye concentration in well number 2 is 1/10 the initial dye concentration times 1/10 the dilution factor, which equals 1/100th. Let's keep going. Now let's take 1 drop from well number 2, which has a concentration of 1/100th, and place it in well number 3, and add 9 drops of water. Well number 3 has a dye concentration of 1/100th times the dilution factor of 1/10 or 1/1000th. So now you get it. The concentration of the initial solution will decrease by a multiple of 1/10 with each dilution. Now I'm going to practice lab safety and put on my safety goggles before I begin the Is Dilution the Solution to Pollution experiment. To begin with, I have 2 cups filled with tap water. The first cup will be used for the dilutions, so I've labeled it clean. I'm going to use the second cup for rinsing my pipette between dilutions, so I've labeled it rinse. The wells on our microchemistry plate have been labeled from 1 through 10. I've already placed 10 drops of RIT dye in the first well. Remember that the dye is a solid dissolved in water and is a 1 to 10 proportion, so we are starting with the 10% dye solution in well number 1. Using the pipette from the rinse cup, I will now take 1 drop of the 10% dye from well number 1 and place it in well number 2. I'm going to rinse the pipette thoroughly in the rinse cup. Next, I'm going to use my second pipette to add 9 drops of water from the clean cup to well number 2. Well number 2 now has 10 drops. Let's record the color of the solution in the data table and also calculate the concentration of the second well by multiplying the source concentration, the concentration of the well from which you removed 1 drop, by the dilution factor 1/10. And again, we'll use the first pipette to take 1 drop from well number 2, and then rinse the dropper in the rinse cup. Make sure you place 1 drop in well number 3. Then, as before, I'll use the second pipette to add 9 drops of water from the clean cup to well number 3. Let's record the color of well number 3 in our data table and calculate the new concentration. I'm going to keep on repeating this serial dilution, taking 1 drop from a well and adding it to the next well and diluting it with 9 drops of water through the well number 10. With each dilution, we'll record the color and concentration of each dilution. The source concentration is always the same as the final concentration of the preceding well.